Come on, Zoom. You did it faster the last time. Okay, so here we are. Perfect. So let's start. First of all, thank you everybody for coming. As we always mention, it's they are difficult times, so we hope all of you are okay and all your family are safe. And thank you very much to all the people that make this possible today. And yeah, so let's start with the beginning, who we are, what we are doing, etc. So many of you probably know what we are doing, who we are, and basically what we are doing from a long time ago. And basically we are a bunch of people interested in technology, not always related with Java, but there are things related with Java. And we are also a non-profit association since more than 8 years ago. And we have a bunch of almost 2,000 members in the meetup. Wow, this is great. And yeah, we are always open to any particular thing. This is I think this event from today is a good example. We are gonna, we did a lot of things. We work with a lot of technology. We play with a lot of things, and we also learn a lot of, let's say, different approaches and technologies, even not related entirely also with Java. So yeah, a few links related with the community. We have Twitter, we have Meetup, we have Flickr, where you can see a lot of pictures related with the events we have been doing. There's also all of our videos are already recorded and uploaded in YouTube. And also we have even Instagram. I forgot always to have Instagram. We are funny and beautiful people. Yeah, so don't look really fancy pictures there, but funny ones. And yeah, I gather, yeah, let's say a small example of the different events in technology we've been having a look. And of course, some yeah, big events that we organize. We organized a big conference 2 years ago. And we gathered more than almost 800 attendees, and a lot of speakers. It was really, really amazing. Let me share with you these pictures that will remind you, different moments about how beautiful it is attending to a conference. And yeah, this is something that we were really proud of organizing and make it available, thanks to this amazing work. And yeah, for this year, of course, based on the situation, it is not possible, to make it, I would say, in person, but we thinking about and what we can do. And basically what we did is to organize something in virtual mode. And basically for next July, next 23rd of July, we hope to gather all of you to join the community and to join the conference. And yeah, we hope that we will be talking about Java, OpenJDK, Kotlin, microservices, Kubernetes, Spring Boot, Quarkus, any technology related with JVM. Well, it will be there. And yes, for sure, this will be free for all of you. So we invite you basically to join the community, to join the conference. It will be amazing. And I hope all of you can attend to the conference. So, and yeah, that's it from my part. I will basically thank all the sponsors that make this possible, basically Dynatrace and also JetBrains, that we, thanks to them, we have some free licenses of their products. And last, as we always say, just please join us, ping us if you want to contribute, to share something, or you want to propose something about the next event. That's always welcome, and we will always ready to prepare something for our next event. And yeah, for today's event, we have a lot of people. Suddenly, Jordi cannot join today because of personal problem. Appeared. Hope his family is okay. And yeah, so that's it. So that's from my part. I still all the time that I've been, stealing time from all of you, and probably we can start from the beginning. So I think, Cristina, you are the first one. So thank you for coming.
Hi, thank you everyone. Thanks, Nacho. So I'll start by sharing my screen. So hello everyone, I'm Cristina. I'm a technical coach at Coach Sherpas. So you can find me on Twitter on this handle, Coach Sherpas, and Cristina Verdi. Okay, and today I will talk about programming without statements. Okay, so the idea here is that I would like to share you how to be more productive and minimize the risk of introducing bugs in your code base by adopting super simple habits, and also combine it with some super cool Kotlin features like scope functions. So now we will see two examples, one in Java and the other one in Kotlin, in order to compare. Okay, so I want to imagine that we are in an application, a hotel application, and this is like a reservations app. Okay, so in Java, you want to update your aggregate and cancel a reservation. Okay, so you would do it more or less like this. You would find a reservation. There's a bug here. There's some bugs over here, and this is not very, well crafted code, let's say. So you would find a reservation, then you have some logic. If reservation is finished, now you want to update your aggregate here, and finally perform some side operations like publish an event or maybe do some logs. Okay, so my point here is that I've introduced bugs over here and are difficult to identify. So for example, since I need to query one reservation, the last reservation, but I also need to find the current reservation. If I don't use good and proper names, I can end up in a situation when I'm actually publishing events from the wrong aggregate. Okay, and it's difficult to read, it's difficult to identify. Okay, so how can we do this in a simpler or more readable and concise way? So let me share my screen. Here we have similar code in Kotlin. So as you can see, the flow is exactly the same. The code is much more concise, readable, and it's easier to follow. Besides, thanks to these scope functions, I'm not able to access a reservation instance outside of the scope of this scope function. Okay, it's not so. It's what's happening here. Why am I able to publish events from a reservation that is not the one that I canceled? Because this variable over here is already, it's still accessible in this line. Okay, so how can I avoid a situation like this? Okay, so it's the same flow. Let scope function returns, it allows us to introduce a variable and we can operate it. I named, so this has a default name, that is it. So I just avoided to use the default name. So this is one of the things that you can do with let. Introduce new variables of I don't know, have better names. Let evaluate to the lambda expression, to the block of code of this expression over here. And then, for example, I used other scope functions like apply. So apply exposes the context object, and we can use it as this. So instead of having, I'm going to minimize something. So instead of having, for example, reservation.cancel as in this case, or this.cancel, I could even refactor this a little more and just be more concise and say, okay, just cancel this reservation. Then I'm using also scope function here. There are some differences that we will discuss later in this scope functions. And finally, I'm also again using apply in order to log something and create a log for this reservation. Okay, so let's look a little bit more in detail in how scope functions are implemented, or why this magic can happen. So as I said before, scope functions allow us to execute blocks of codes, that is lambda functions, on objects. So how we can do that? So by passing a block of code, a lambda function, and for example, let scope function does that and evaluates to the expression of this block of code. Okay, then we can also have a receiver. This is like the object you want to apply the operation on, then an operation, a function, and evaluate to return what to the same result that this expression over here. And similar things for their scope functions. So that was pretty much it. I hope that you learned a little bit about the power of scope functions. I think it's really easy to read or follow code this way. It's also easier to avoid introducing unexpected bugs. And well, I hope you liked it. Thank you very much, everybody.
Thank you, Chris. You're on time, so perfect. Let me see if there are any questions right now. So right now, we don't have too much questions. I have one. This is the mechanism. It's called like currying, where you are transforming functions and translate to another function. Is something like similar to this?
Yes, well, it's not exactly the same. It's like a pipe. So we have a function that accepts in Kotlin. Functions are first-class citizens. So this means that you can pass it as arguments, then assign them to variables. Okay, you can operate with them as any other expression. So basically, scope functions receive other functions, that's the power of them, and create a temporary scope. And then they have a return value, and then you just keep operate or
processing.
Yeah, processing them. And the advantage is that every object in Kotlin has access to these scope functions.
By default.
So it's exactly by default.
Mm-hmm. So it's not like in Java, you have the streams, no, and only you can do, let's say, process the streams only on streams API. So every single object in Kotlin, you can do it in that way, and then basically you can apply some functionality to everything you would like. No?
Exactly. Exactly.
Okay.
It's super powerful.
I like it. I like it. So thank you very much. I would say that probably with combination with ethers and this kind of components could be more powerful, because then you can process everything and then do whatever you want, concatenating all this process, right?
Exactly.
Okay, got it. So thank you very much. Still will have questions? No. So time for the next speaker could be Uriel. So.
Hi everyone. I'm going to talk about functional error handling with Arrow. I'm Uriel Salischiker and I work as a software engineer in Dynatrace. So let's imagine we're a movie critic and we want to write a review. So the process can go something like this. We turn on the TV, we watch the movie, and then we write the actual review. A simple model that we are going to use for the rest of the talk looks like this. We have three classes, a TV, a movie option, a review, and then three functions, one to turn on the TV, one to watch the movie, and one to write the actual review, not including the arguments for simplicity. But what happens when things start failing? With exceptions, we could have something like this, where we fail to turn on the TV because we can't find the remote, or we fail to watch the movie because it's not in Netflix and we're an independent movie critic that can afford more than one service. Or I'm just putting both approaches here. It doesn't matter that I'm using a runtime exception and a name exception here. So what are the issues with exceptions? The first one is that we break referential transparency, as the same function might throw at one time or return the correct result in another. They are basically a broken Goto, which results in a lot of issues when you are trying to wrap it in a sync task or in futures. It might result in big try-catch blocks, and when devs are lazy, they might catch more than we intended. And they are quite costly to construct, as the JVM has to work the entire stack to generate the stack trace. They are also a poor choice when we are trying to model absence, when something is just an alternative path more than an error. We're dealing with async code, or when your final users don't really have access to your source code to find why certain exceptions are thrown. They are, however, useful when you want to model fatal errors that you can't recover from, when you are a contributor to the JVM internals, where they basically abuse them, when you want to create chaos and overthrow the government, this talk, when you know what you're doing. So how do we model errors? I'm going to give some examples using Arrow. One option is using option, which is kind of similar to the nullable types in Kotlin, but it has some extra nice operations, like you have a map, you have a filter, but again, it's basically the same. It has some nice functions like this none and some to actually generate the actual options. But you can basically think of them the same as you will just put the nullable in any Kotlin type. Then we have also the either. We have here, we actually model either a left value or a right value. By convention, the left value is generally the error, while the right value is the correct value. Here we are using seal classes for our errors, so the compiler actually checks that we're handling all cases. So I have a seal class review error, which has a remote not found and a not in Netflix errors. And each of the functions just returns this either the remote not found or the object. And to use it, we can just add a bind after each of those functions and wrap everything in a either block. And Arrow will actually check if this returns the left part of the either, it will terminate here and return that value. If it returns the right value, it will save it here on the variable and continue with the next line. That way you don't have to have 20 million if statements checking for every error condition like you have in Go. And at the end, we can just fold the result. If it was successful or it was the right case, we just print out the review. Else, we just check each of the errors. And we actually check here with the when, meaning that the compiler checks that we are not missing any of the errors. Another less common way, I actually haven't seen it used in production, but it's really interesting, is using the validated class that Arrow also has. We have a series of errors and a series of fields. Here I'm just defining 3 errors that does not contain, max length and not an email, and a form field and an email field. We basically need a lot of boilerplate then, which is really not that important. I'm going to share the slide deck afterwards in the chat. Plus, you can just copy it from the documentation in Arrow. They have this exact example here. But basically, you define all of your rules and some strategies. Those strategies mean that if we have 3 invalid form fields, for example, we can either fail fast, so it will just return to us the first error, or we can accumulate all of the errors and just show them in a list. So as a quick, too long, fell asleep, didn't watch the presentation. If you want to model absence, you can use option or nullable. If you have known alternate paths that are not really errors, you can use either. In older versions of Arrow, you also had try, but they replaced them with either too. And if you want to do validations, you can use either or validated. So, thanks.
Cool. You were so fast, Uriel. So not sure the people had time to analyze everything and gather some questions, but I have at least 1 or 2. So one is, for example, how good is the documentation, Arrow's documentation? I mean, is fair enough? Okay.
So it's made by the community. it has some really nice parts that are really understandable, and then some where they just go completely into theory and it's almost impossible to parse. This is actually based on their documentation on error handling, just a bit more condensed to be used as a reference, because they just go into all of the functional programming theory, and it becomes a mess to actually quickly find things out.
Okay. Okay. And then another question that came to my mind is how difficult is to use, let's say, Arrow, or to include Arrow in existing project?
Yeah, let me share my screen real quick. So when using either, which is the main issue in my opinion, in older versions of Arrow, you actually had either.effects instead of just this either block. But I think after 0.10, they changed it. So everything with side effects, including either, has to be marked as suspend. So if you are using either just for error handling, then you need to also note that it's running under a coroutine. So you need to do a run blocking or something similar. So that's one of the changes I don't really agree with. But yeah, apart from that, you can just go to the code, copy the either classes if you really want to, without copying the entire library. Or you can just use an older version, or just write everything as suspend, which is nice on its own. I actually have like 2 or 3 personal projects. We just added them on there, and even people that were not really familiar with Kotlin picked them right away. So it's not that hard to learn.
Okay, thank you. Not sure there are any other questions. No, there are no more questions. So thank you, Uriel. Time for the next speaker. That could be
me. Yes.
Go ahead.
Okay, so as you hopefully see on the screen, I'm gonna be talking about monads. And the thing about monads is they've been explained 1,000 times on the internet. And the reason for that is because whenever you look up for the definition of a monad, it's very technical. It goes into symbol theory. And it's just generally hard to grasp. But once you try out to make one, it's very simple. And the first thing you do after that, it's kind of an unwritten rule, is you either write a blog post, or you make a YouTube video explaining it, or you make a lightning talk. So what I'm going to do is, I don't have enough time to go into depth about monads. I'm just going to show you code of the most simplest monad possible. Then I'm going to make it a slightly bit more complicated in order to have actually something useful. And at the end, I'm just going to point out a few classes that all of you are familiar with that are monads. And the nice thing is we have actually already seen multiple monads in the last 2 presentations. So maybe you can already spot it. But yeah, let's maybe start with the first question. What are monads? And if we condense it down and break it down very much, a monad is just a class. More specifically, a class that wraps some kind of raw value or multiple raw values. And this class also needs to have 2 functions. The first function is usually called unit, but in Java, we usually call it off. In Kotlin, it would probably be something like monad off, to be similar to list off or set off. And this function just simply wraps the raw value and returns a monad. Very simple function. The second function is almost as simple. That's the bind function, but usually in many languages, including Kotlin and Java, it's called flat map. And what the flat map does, it's essentially a method on a monad that returns another monad and takes a function in that transforms the raw values into another monad, and then it applies those functions to all of its values and aggregates the result and returns it. And that's essentially it. I'm sure all of you have seen these 2 methods a lot, and maybe now you realize some things are monads. There's technically 3 more rules, 3 monadic rules that these methods need to fulfill. They essentially just tell you how these 2 methods need to interact with each other. The nice thing about this is we are all familiar, most likely, with both of these methods. So we are automatically going to implement these correctly and automatically going to fulfill those rules. And that's also the reason why I'm not going to go into them in depth. They are on the slide deck, and Nacho or me will share it after these presentations. And then you can go look them up if you want to. But maybe the second question that arises is, why should I care? Why should I care about monads? Well, if you go back to the original monad that we had before, it's nice that we wrapped some raw values, but we don't actually get any value out of it. It doesn't actually do anything. So let's look at the monad that's a bit more useful. And it's actually a monad that we've already seen before today. And in functional theory, it's usually called maybe. You've seen it as option before, and it's similar to the optional in Java. But essentially what we do now is we don't have only one value. We also have a second Boolean value that tells us whether or not it even has a value. And what we also do is we don't always apply the flat map to the value. We only apply the flat map to the value if the has value is true. And this is just the very basic functionality. And the nice thing about this now is that we can do stuff like this down here. We get a monad in, and we do not have to care whether it has a value or not in the first place. We can just use flatmap to add 5 to it, or multiply it by 5. Then we can have a flat map and half it by 2, but only if it's integer divisible. So if it's not integer divisible, we return an empty monad. And after that, we don't care whether we already returned an empty monad or whether we return actual value. We can just use it again and add 10 to it. And thanks to this, we can just apply a lot of functions. We never leave the domain of maybe, which is something very important to API design or good API design. And still at the end, if you care about it, you can see, hey, did at any point in this step go something wrong? And then we can care about this. This is also something that is very popular in, for instance, asynchronous programming, when you have a promise and you don't care too much about when it goes wrong, but you say, let's just make this request. And when you're done with it, then do this, and then do this, and then do this. And sometime at the end, we just say catch. And if something goes wrong, we just have to care at this one point, and we don't have to care at any of the other points. And generally, this is a very useful construct that I'm sure you will find in a lot of APIs. And I hope that you're going to go through and recognize some monads in the future. But I've also selected 3 monads of both Kotlin and Java that are probably the most commonly used ones. In Kotlin, we have iterable, which is very useful because all of the collections in Kotlin are iterable, which includes list, set, map. We also have sequence, which is kind of like a stream in Java. And we have nullable types, which at first might not seem like they're monads, but they actually do fulfill the monadic laws thanks to the let function that Cristina shared with us before. Because if you apply the let function conditionally with the question mark in front of it, it behaves like a flat map. And yeah, in Java, I already mentioned optional. We also have stream and completable future, of course. And yeah, that's it. I hope that you will recognize some monads in your future code and library usages. At the very end, I just have a few interesting links that you might want to click at. The first one is just my presentation. Second one, probably best explanation that goes a bit more into in-depth about what monads are with pictures and everything. And last one is just a question of why they arise in functional programming, because in heavily functional languages, you just automatically arrive at monads. But yeah, that's it from me.
Cool. Thank you, Oscar. I have to say that I've been having a look on different talks around monads, and normally all of them are going to be, really abstract in terms of what they're doing and how, etc. And in your case, I think it was really clear, nothing really, I would say, complicated. And also, I would say that it was really easy to understand. So congratulations for that, because
thank you.
It's not I would say an easy concept to explain. Let me check if there are any questions right now. No,
I've already seen that somebody correctly identified some monads. Alejandro.
Yeah, Alejandro.
Correctly identified optional streams and completable future as monads in Java.
Yeah, exactly. Yeah, but there are no questions for you right now, and yeah, I don't have it right
okay
now. Yeah.
I will
Thank you very
share
much.
my slide deck after everyone is done, so nobody gets
Thanks.
confused.
So, time for the next speaker. I think is Valeria. Yep.
Yeah. Okay, so let me share. So if you see it correctly, I'm going to talk about Jetpack Compose, like an introduction and a few examples. So I'm Valeria, Android developer for Akvo. So if you want to try Jetpack Compose, you need the canary build of Android Studio because it has a good support for although you can open projects with a stable Android Studio, it's better to use this version. It's for Android is minimum SDK 21, so only, well, almost all devices, but still. It only works with classes in Kotlin, and it's still in beta. I recommend to use Kotlin 1.4.32. I tried it with 1.5, but I had some issues. So, and there is a JetBrains version composed for desktop, so it works on. You can create apps for Android and for the desktop, for Mac and Windows and Linux. So, well, here is the typical Android Hello World example with the activity, the XML layout, and the emulator on the right. Very simple. And the same in Jetpack Compose. It's you can see everything is now in one class, and you have a preview on the right, so you don't need, well, you can start without an emulator and see the previews. So a few features in Jetpack Compose. The default arguments, so you don't need to use overloaded functions. Higher order functions, there are functions that receive functions as parameters. Lambdas, you define the function in line with the lambda expression, and there is a special syntax for trailing lambdas. So if the last parameter of a function is a function, the lambda expression argument can be placed outside the parentheses. And if lambda only is the only argument, then the parentheses can be removed. So you can see the example on the left image and on the right. The right one is how we use it. And now I will show you a bigger example. So this is a list of dogs, and in Android, this is so we will show the list with using lazy column, and it's similar to recycle view. So it lays out only the visible items, and one item is, well, you can use column, which is a bit, well, it's quite obvious, vertical sequence of items. Then there is something that is state-backed properties, which is used a lot. Then we have box. Well, it places the items one on top of the other. So here you see how the state is used. So the button click, it makes a change on, and the UI is updated. Yeah, and here you have, this is how you show these previews on the right. Okay. So now, shall you use Compose? Well, the advantage is I found that the documentation is great and there are lots of examples. It's fun to try out. There were some challenges by Google and they were fun to do. It's quite intuitive to use. You can use it for Android and desktop, but well, with Compose for desktop. It's in Kotlin. There are less code than with Android View. So in the previous example, it was like about 150 lines. And if you have to write the same in Android View, it would be multiple classes with an adapter and view holder. And so it's much easier. And the toolings are really great with the previews, and you can even enable clicks and in the preview. And the version 1.0 is coming soon. They said it in the Google I/O. And you can also use it together with views. Well, you can migrate slowly. It can coexist with views. But the drawbacks, it's for now it's beta. Also, yeah, the errors I found with builds when you switch versions, you can have some strange errors. So, but it's normal with a beta version. And the minimum SDK, maybe that won't work for you if you have apps in countries where they don't use recent fonts. And also some views are not supported in Compose, like the advertisement and map view, but it's easy to integrate with Android views. And yeah, here are some links. I will share the slides. And yeah, if you have any questions, I don't know everything, so, but I will try my best.
We don't know everything, Valeria, so don't worry about it. I think we have few questions, but one is mine. Let me check because now my Zoom controls where they are. So yes, we have one question that says, can the documentation for Jetpack Compose be used for Compose for desktop? It seems that it's difficult to find documentation for it.
So I used the Android one, but in the slides there is a link to the Compose for desktop, and they have some examples in GitHub. And from what I see, the syntax is very similar. Of course, there may be some things that are different because it works for both desktop and Android. But I will share the GitHub link. But I think you can try for Android. You have to use the Android Studio, and then it will be easier to also to move to desktop, I think.
Okay. Not sure if the question is answered. So there another question from Pep says that so recycler view is over.
Well, so because first you need to support for now the older devices, you cannot use Compose. It's still in beta, and yes, it seems that Google really wants to push it because they said the release is very soon, and they created a lot of motivations for developers to try it out. So, but I think once you have you try Jetpack Compose, you will see that it's much easier to use. If you can, but there are the limitation, of course, with the older devices. And if you you don't want to migrate all your app all at once. So
Yeah. Makes sense. I have one question that for me, I'm not an Android developer, and what is completely weird for me was like you have to use, you mentioned, no, an Android Studio that is a Canary version, no? It's like it is not, and also you mentioned that it's already on beta version. It's like, but this product is from at least 3 years ago, no? It's something like
they started development, I think, 3 years ago.
But this basically because Google is you have your product for free and it's a beta and it will remain beta for a long time, or I mean it's ready to use in production, I guess.
They are trying to to push it, but of course in the documentation and the website it says it's still in beta, but I think now it's gonna be released soon. So they are trying to get a big user developer base to to start using it. I mean, better for them before even the launch. I guess maybe it's a strategy.
Yeah, probably. Yeah. Let me check if there's any more questions. No, I think there are no more questions. So thank you very much.
Thank you.
Time for the next one. I think it's Piotr.
Yep. Everyone, let me share the screen. Can you see it now? Awesome. Okay. So I'm Piotr Krzemiński, and today I will show you Kotlin's approach on entering the front-end development world. So let's assume that I'm a backend developer that needs to create a website. So I'm a complete stranger in this world. There are separate tech stacks, different problems. So what should I do? Okay, the first choice is the default one. The obvious one is JavaScript. So I played with it like once or twice, but it behaves a bit weird at times. The internet is boiling with funny jokes about this. I wouldn't feel confident having to onboard this ship, given that, for example, I come from Java, where everything is like typed. So what else do we have? We have Git. Oh, okay, so I can create websites in Java. That's awesome. So it's created by Google, so you know it's good. By the way, it's almost dead. Companies are migrating away from this because you can get no security patches and the bundle size is like several megabytes. So it doesn't sound like something I would like to invest my time into. Okay, so what does Google use nowadays for their own products? They create a lot of web stuff, right? Angular. Okay, is it like a language? A framework, okay. And what language is used there? TypeScript. I like this name, type. I would love to type everything if I could. So tell me more. Okay, so this is from Microsoft this time. Is it like another dead technology? No, it actually looks like a current industry standard. It's a great gradual way to provide typing to the messy JavaScript world, and the types are optional. So what if I want to make the types mandatory? Okay, so there's a tsconfig.json file where you can tweak the compiler to force certain typing rules. And there's also a ESLint and created sets of rules that ensure that the types and other TypeScript features are used properly. In Java, we have this check style as a linter, and I can skip some checks, for example, for a given line or file. So can I do the same here? Yes, we can. So it looks like in some cases, the safety provided by the language and the linter can be opted out. And if your diff is really long, you may not notice. But hey, let's admit this, that TypeScript is actually a really smart step on the way to make the JavaScript world a safer place. The ability to incrementally migrate to TypeScript makes onboarding a pretty simple task. It's easy to pick up by JavaScript developers, plus after an initial setup and learning a few things, even backend developers are happy with it. Given this gradual approach to migrating from JavaScript to TypeScript, the Microsoft guys did a pretty good job. Today, though, I'd like to show you what might be the next step after TypeScript if you want more safety at the cost of not so gradual migration. Imagine Java that doesn't go into the direction of GUID, but is rather closer to the actual JavaScript API. Then try to make this Java a bit more like TypeScript in terms of syntax, but make it safe by default so that no linter is needed to ensure some basic stuff. You've got yourself a Kotlin with a JavaScript runtime target, in short, Kotlin.js. Given that Kotlin is easy to onboard if you work with Java, Kotlin.js feels like almost coding in the backend, but actually targeting the frontend. Syntax-wise, you know these languages comparison pages, like one side, one language, the other side, the other language. So there's also the one for Kotlin and TypeScript, like you see on the slide, and the differences are really subtle and make Kotlin look familiar to TypeScript developers. Okay, so we've got ourselves a pretty safe and convenient wrapper over JavaScript runtime, but we won't use like a pure JS API or jQuery, right? So what about using some modern frameworks like React or Angular? So for React, there's a Kotlin library that provides a Kotlin internal DSL that mimics JSX or TSX markup. It looks like this. It doesn't look exactly like we would expect, but after some time, it's easy to get used to it. Plus, we get all the perks that come with the fact of using Kotlin, for example, powerful refactorings. Putting it all together, this is one of my pet projects which is about synthesizing music. The frontend is written in Kotlin.js and in React with using Material UI components. So the backend, like the logic, is also written in Kotlin and compiled into JavaScript. As a bonus, if we use Kotlin.js, because of the fact that you can use Kotlin also in the backend or in your mobile apps, you can share code between these platforms. So my synthesizer actually works as a Java console application also and an Android application. And I could also add a target for iOS and even more. It turns out that you can write platform agnostic code, Kotlin code that doesn't know anything about the platform. Then you can only add the platform specific pieces so that you can like glue it to the platform specific API. So imagine what time savings you get if you maintain only a single common code base where you implement the core features and only implement the needed pieces for the platforms. It's like huge time savings, and it can even save your reputation once you fix bugs for all platforms at once. So there's also some experimental treats in case you have a Kotlin backend and a TypeScript frontend. You can use a new Kotlin IR compiler to generate TypeScript typings. However, please keep in mind that JUGgers is still in its early phase of development. Last time I tried it had major stability issues. However, in general, the idea is pretty awesome, and it's another example where Kotlin's multi-platform nature would truly shine here. So I'm like really can't wait to use it daily. So that's all for today. I highly encourage you to play with Kotlin.js. If you have any questions, feel free to ask them here on Slack. Thanks a lot.
Oh, thank you, Piotr. You were on time. I mean, no more than 7 minutes already. Perfectly timed. So
glad to hear it.
Yeah. Let me see if there's any questions. We don't have many. So yeah, we have one question here. Is that NPM libraries directly in Gradle?
When you use Kotlin.js, there's this Gradle function called npm, where you can actually put a dependency on an npm library, and it's just behind the scenes, it will download either npm or yarn and will fetch the libraries for you. So yeah. And also I can see another question. Can you actually generate JS from Kotlin.js? Yeah, well, that's the point. So you will get the JavaScript which is ready to run, but the code won't be that readable for a human being. So, you know, the compiler does its best to generate what runs efficiently. So don't depend on this, like, don't treat it as a converter from human form to human form. It's just to run the code on the target platform.
Yeah. Thanks. So yeah, go ahead. Oscar.
I actually have a follow-up question on that. Can I just put a d.ts file in my project? So for those who don't know, d.ts file is just type definitions that tells TypeScript what type certain functions have if you only have them in JavaScript.
Yeah, so that's the goal of JUGgers. So the goal is to provide DTS files and it will generate Kotlin code. And the project is, like, as I said, still pretty young. So it works for some simple cases, but I guess it's not really there yet to use in production. But I guess with the current pace of development, it will be ready in about a year or so.
Okay, cool.
My question was going related to that. If we can use it right now in production and do it everything from the backend side.
Yeah. So on one hand, Kotlin JS in the classic compiler is already stable. But on the other hand, Kotlin JS with the IR compiler and some features like JUGgers are either experimental or alpha. So formally, it's not yet really stable. But on the other hand, I know some cases where companies went like all the way to Kotlin JS, or they simply used it in some projects, like for some governments, like small government pages, and it just works. So a rule of thumb that I use is if the service has pretty not that important visibility, or you are familiar with Kotlin JS, so like you have some experience, I recommend going forward with this. Otherwise, just let's wait for it to stabilize and be more mature.
Makes sense. Another question came from Marwan. Marwan, I'm not sure if I already.
What about
Budding paired with Kotlin? I don't know if you know Budding. Budding is a Java framework for building UIs, let's say, similar to CWT, I would say.
Okay. Actually, I cannot answer this question. I don't know much about Vaadin, but in general, Kotlin JS works everywhere where you expect just a JavaScript runtime. So if there's a way to, for example, use pure JavaScript with Vaadin, then I see no problem with using them.
Okay, thank you.
Thanks a lot.
Oh, people say that I have my volume too low. Yes, my microphone is here and I have to come here to speak louder, but there are things I have to, sorry, but the people complain about this. I try to not disturb too much. So thank you, Piotr, for your talk.
Thanks
and
a lot.
I hope that we can continue with the next one, which is Uriel.
Yes, thank you, Nacho. So let me share my slides. So yeah, well, the last one, I would like to make it painless, let's say. So I'm Uriel. I'm a software engineer for Dynatrace. This is just some information about me, but yeah, since I'm the last one, I will skip this one. So right to the matter. This talk is about building command line applications with CliKt. CliKt is a library that is just experienced. I did some experiments with it. This is the definition that is provided by the library. So in short, it's a library to support you for building command line applications, and it has everything that you could expect. So we will try out a few things and just building a simple command to get started. Some numbers about CliKt on GitHub. So it's created by this guy, AJ Alt, that it has. It's really responsive. So if you check the Jira tickets, it's always there and trying to respond to everything. It has 31 contributors, 1,500 starts. It has like 10 releases since beginning to 2020. So it's kind of stable. And it has a really, really nice documentation on the website. So if you want to check all the capabilities, all the different options that you have to build a command line tool, there's tons of examples, and everything that you would like, it's over there. So we'll try to build in this time like an echo command. I'm pretty sure that you are familiarized with it, but it's just a command that writes strings into the standard output. And it has like few options. Yeah, we'll jump directly into the implementation. So first of all commands that are implemented by CliKt, you need to inherit from this class that is called CliKt command. And then when you inherit this class, you get like few goodies, like for instance, getting this all the parameters injected to your class. As you can see here, we are defining the strings argument, which is a positional argument, and it can appear multiple times. And then we just implemented one flag, which is the do not append new line. So it means that if you add this flag, each echo won't append the final new line character, which is a bit weird, but anyway. And then finally, the actual implementation of the command, which is in here, is not implemented yet, but when you override this run function, this is what actually will be called when you trigger the command. And of course, the entry point is number 4, is how you call this command from the Kotlin main function. This is just, let's say, proxying the call to main with all the arguments, and it will do its magic. So with this current implementation that we are just seeing, what you get for free is already, even with the to-do, you get already the help. So, well, just as a hint, in case you want to try out, you need to run, install this command in Gradle, in case you're using Gradle. So you build the executable command, and then it will be inside this folder app build, install, app bin, app, whatever, right? So just to give you some hint. But at the end, the important thing here is that from the definition that you wrote on the parameterization, you get this nice formatted help. So you can provide to your consumers how to use your command. And then let's jump into the implementation. So the implementation is just, in this case, it's pretty simple. So we get a list of strings. So in here, Kotlin will infer the type of list of strings. And in this case, we need to join them by definition of the echo command into using spaces separator. And then we need to revert, let's say, the behavior of this flag, because the echo function that we are using is kind of a special function, and this is provided by CliKt. So we could just here print ln and just rely on Kotlin to do it. But the thing here is that CliKt command provides an abstraction on the console, and this is much handy in the case that you want to test your command, because in that case you can inject this console and later on answer what's the console receiving, right? So that's why we are using here the echo, and we will see the example of how to test this. But to test this, we need to implement our own console, and in this case, I just name it test console. And it's a pretty simple implementation. So every time you receive a print, if it's not an error, well, if it's an error or not, you will accumulate just the text in a separate collection. And yeah, so in this case, you can later on inspect these collections and see what you have added in there. So this would be how a test would look like, right? So you just instantiate the test console, then you run your command. This is the hooking into the context, and you specify the test console. Otherwise, you will use the default console, which is using the standard input, output, etc. And then you provide the array of arguments that you want to use. In this case, we are using the -n and the parameter full. So then you can expect that we don't have the break line in the end, and you are just receiving the full. So pretty dumb, but it makes a nice example of how to test command line tools that it's not always so easy. So what are the goodies provided by CliKt command? So as you see already, you get like the nice formatted file command for free just by specifying your command using the API. Then you can have all kinds of parameterizations that you can think of. So arguments, options, subcommands, whatever. And then all these patterns that you can extract within. So if you want to validate, if you want to have type conversions, if you have multiple values, flags, whatever. Then another thing that we already saw also is the abstraction from the console, not only from std out, but also from std in and std error. So if you want to, for instance, simulate some prompt or some interaction with the user or some error, you can also check that. Then there also it provides auto-completion for different shells implementations. And I'm pretty sure that there is much more. So I recommend you that if you're interested, please check the website because it's pretty well documented. And then finally, it's just some lesson learned from my side. So yeah, I'm just trying to be bold here. It's pretty important, the help, right? Because as command is something meant to be used by command lines, it's pretty important to have some way to inspect how to use that, right? Otherwise, we don't have any UI whatsoever, so it's really important. Also, the side effects, it's also important to create an abstraction on top of it. Fortunately, CliKt already provides this by this console abstraction. Then also, in case you want to create like more complex commands that they are changing a system or a host, just be aware that end-to-end testing, if you want to test everything, it can be a bit tedious because imagine that you want to implement a copy command. Probably you want to have a setup phase where you, I don't know, create some files, and then you will have a verification that you verify that both files are the same, and then you need to tear down or remove those files. This would work for a copy command, but then imagine that you are dealing with processes, and you can have a mess with your process where the tests are running. So in this case, maybe containers can help to have like an isolated environment to run those kind of tests. And in this case, probably test containers is a nice leap to take a look at. And yeah, and as usual, when talking about libraries, I would say that, use the library, don't reinvent the wheel, and try to use it with all its power, but also keep this, your safety net to in case that there is something on the library that's not so cool, or you want to use it in another way, or that you can always abstract from it and do your own stuff. And that's it from my side. If you have any question, I will be happy to answer.
Thank you, Oriol. Let me see if there are any questions. I have some.
Okay.
One is basically how it works for, let's say, for the auto-completion. You mentioned something about the auto-completion on the bash and shell and these kind of things. How this works? It's done automatically, or you have to do something?
Yeah, basically you need to. There is two ways of doing this, and it's pretty well documented on the website again. But there is like that you can call your shells, your command in shell that it's created in a certain way, and then save this output as another shell script, let's say, another shell file that then you can use on your RC file to load this, and this will provide already auto-completion out of it. So that's the most simple way. And then there is another way too, is that from triggering this from the library, but then you need to somehow provide a way to trigger this, either providing an option or a flag or a subcommand, whatever you want to, and then you can make the explicit call to the CliKt command function to do it. But yeah, since it only relies on the parameterization, that it already creates a help, but also it creates the auto-completion for free, basically.
Okay. Nice. And also one thing that for me, I would like to know how it's possible, let's say, to have kind of a hidden parameters just to see, okay, this is the documented ones and we have something special and just to...
Yes, I think so, like an Easter egg or something like that. So
typical debug flag that everybody knows that is somewhere,
I believe so, because I think that you can always tweak what is shown in the help message. So you can provide, if you don't provide any help or any documentation, it will create out of some documentation out of the box. So considering your variable names and things like this. But there is, I think, also always flags to say, I don't want to show this in the documentation. But in this sense, it's pretty flexible to how do you want to show the things.
Cool, thank you. So I'm not sure if there are any more questions here. I cannot see it. So Piotr has to leave. So yeah, I have to say thank you all the people involved in the session. I have to say thank you to all attendees. Let me see how I can stop here, because I think basically we can stop the session here.